Welcome to today's webinar brought to you by Materialize, Nexla, Acante, and Cambridge Semantics. I'm Stephen Faig, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Top Trends in Modern Data Architecture for 2024. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we're excited to have with us Jessica Laughlin, Head of Product at Materialize, Saket, Co-founder and CEO of Nexla, Dhruv Jain, Chief Product Officer at Acante, and Sean Martin, CTO and co-founder of Cambridge Semantics. So each speaker today is going to provide a brief presentation on this topic, and then we're going to dive into a group discussion. So without further ado, I'm going to pass the event over to Jessica to get us started. Welcome to the broadcast, Jessica.
Hi, Stephen. Thank you so much for having me. Hi, everyone. My name is Jessica, and I'm the head of product here at Materialize. Materialize is an operational data warehouse, something that we'll define and dig into in this presentation, and something that I think will be a big trend in the modern data architecture this year. To understand what an operational data warehouse is, let's first motivate when and why you need one. Working with static data has come a long way in the past decade. With big data tools, the move to the cloud, and the advent of the analytical data warehouse, it's never been easier to work with vast amounts of data. But the same advancements haven't yet taken place for streaming or real-time data. Building with real-time data is still a big investment. You have the option of hiring a team of low-level streaming experts or deciding that your engineering team is going to spend their time building and maintaining custom microservices to handle your real-time needs. This means that for most folks, processing streaming data is still out of reach. But if building with real-time data wasn't such a challenge, wouldn't we all want to? It's better to know right now if a production line in your plant is malfunctioning, how your ad campaign is performing, or fraud is happening right this instant so you can stop it in its tracks. In some of these situations, it's imperative that you work with the freshest data. But in most others, wouldn't you want fresh data if it were as easy to work with as batch? So we have straightforward ways to process batch data, and we can think of that as our analytical data. Analytical data is all of that data that your business generates over its lifetime. Whether it comes from your sales tools, your SaaS applications, or is user-generated, it spans back over months and years of time. And this is the type of data that you run big, complicated queries over in your data warehouse to understand how your business has performed in the past. But many of us don't have a great way to build with our operational data, the data that's being generated and collected right now in the last few seconds or minutes. Yet this is the data that we want to take action on. As a high-value user hops onto your site, or as new sensor data comes in, you want to be able to act immediately. Where building with analytical data tells you about your business in the past, operational data lets you build on the present to determine the future. But unfortunately, the batch ecosystem today isn't built to let you do this. If you're processing your data in batches, you probably have a setup that looks something like this. You generate or collect your data in your relational databases and your SaaS tools, and then you funnel all of this data into your analytical data warehouse using some sort of ETL or a data movement tool. And you want to get all of this data into your analytical data warehouse because it is the first place in your architecture where you can join against all of your business's data. But you can only move data to that warehouse so quickly. For many folks, that looks like 30 minutes. And you can pay more to move your data faster, maybe even get down to 5 minutes. But as the price grows and the size of your data grows, you're going to start bumping up against diminishing returns. So if you want to act on your operational data the moment it changes, you need an operational tool. Materialize is an operational data warehouse, purpose-built to keep the results of your SQL queries up to date as your data changes. So just like with your analytical data warehouse, you can send all different types of data to Materialize, your relational data, your SAS data. But with an operational data warehouse, you can act on your data the moment it changes. You don't have to wait 30 minutes. You don't even have to wait 5 minutes. With an operational data warehouse, you can act on that changing data in milliseconds. And you can query that data live or use that to power your operational dashboards. You can use your changing data to power real-time applications, or you can push it back out to your SAS tools using a real-time reverse ETL integration with tools like Census or HighTouch. And you can still send that data back to your data warehouse, your Snowflake, your BigQuery, your Databricks. So when you get past that operational window of time, you can still run your big analytical queries over it. So like I mentioned, how Materialize works is we keep your SQL results up to date over your changing data. This means you get to build with streaming data, but keep the comfort of a language you're probably already familiar with, SQL. So you create your views, and just like you would in any other database or data warehouse, but then when you index those views or create a Materialized view, that's our indication to keep that up to date on your behalf. No refreshes necessary. And under the hood, Materialize is keeping your results up to date incrementally. We do this work on write when we read that data in so that your reads are free. You won't have to wait for us to recompute or recalculate results. They'll just be available to you and any other user of Materialize within milliseconds. And even better, we provide consistency guarantees over your streaming data. So not only is your data fresh, you know that it's correct each and every time you act on it. So today I'm going to tell you about how one of our customers is using Materialize as an operational data warehouse in production. For those of you who aren't familiar with Ramp, they're a popular corporate credit card startup here in New York, and they've been working with us over the past year to detect fraud in real time. There are two types of fraud we'll talk about, which is account takeovers, when an attacker logs into an account with stolen credentials, and transaction fraud, when stolen cards are used for unauthorized spend. Regardless of what type of fraud is potentially occurring, every moment counts. On the right-hand side, this is a quote from Ryan Delgado, staff software engineer of the data platform team at Ramp. When fraud happens, it happens really quickly. And Ramp is liable for every dollar spent fraudulently. So shutting this down as quickly as possible is critical to their business. But as you might imagine, Ramp was unable to detect and shut down fraud in real time using batch-based tools. They started by running 30-minute jobs, but as they added more and more data and as the complexity of their logic grew, they were struggling to generate results in the same time period and then even in 60 minutes. Batch-based tools trying to compute operational results just didn't scale, and it was becoming increasingly expensive. So the team over at Ramp chose to bring in Materialize as their operational data warehouse, switching us in for their analytical data warehouse. With this new architecture and nearly reusing the same SQL they had already written, Ramp is now able to reliably detect fraud within 1 to 3 seconds. That's 29 minutes and 57 seconds faster than their batch-based solution, even when everything was working perfectly. And that difference is really adding up. Ramp measured that for account takeover attacks in August of last year, 50% of hacked accounts were flagged before fraudsters could spend any money at all, and they saw a 60% reduction in total monetary loss compared to previous account takeover events. So not only was the Ramp team able to simplify their architecture and reduce their infrastructure costs, they were able to meaningfully reduce the amount of fraud they were seeing in their system. This is a great example of operational data and the operational data warehouse, when you absolutely need to act on the most recent events, the correct most recent events as they're occurring. So if you're watching this presentation and thinking there's a use case in your organization where you could benefit from acting on real-time data, we'd love for you to try Materialize. If you swing by our website, you can sign up for a free playground account or a trial, and we can talk through what problems you're trying to solve in your organization. Thank you all so much for having us here today. I'm really excited to watch the other presentations and chat later on. But in the meantime, please feel free to drop any questions you have for me in the chat, and I'll hand the mic back to you, Stephen.
Thank you very much, Jessica. Before you go, quick question. What do you think is most critical for customers to consider when they evaluate an operational data warehouse solution?
Over at Materialize, we think about three things: trust, scale, and ease. So if you're going to act on your data the moment it changes, you have to trust that it's correct. You need that solution to scale as your amount of data grows or your number of use cases grow. And it needs to be easy enough to do, because I'm sure we're going to talk about this today. Switching your architecture is hard. So you need to eliminate friction wherever possible. So that's what we think about over at Materialize.
Understood. Thank you. Saket, as a segue into your presentation, can you tell us how you bring data into these operational systems?
Thank you, Stephen. Absolutely happy to share how this all works. Of course, as Jessica said, operational databases are solving a critical sort of real-time use case for customers. What becomes important in this case is to take all these events that are happening across different systems and bring that into the operational database. And that means the ability to have real-time connectors that can take the data, stream that into these systems, and requires a data architecture that can support this sort of a use case. Let me talk a little bit more about that in the context of Nexla. And to introduce myself, I'm Saket, co-founder and CEO of Nexla. And what Nexla does is it brings automation into data engineering as a practice that is becoming increasingly in demand to serve the needs of growing demands on use of data across different business functions. So to chat a little bit about that particular need in the industry, let me share with you some of the challenges that companies or teams are facing today. When we look at the middle part of this diagram, we see a sort of an inverted pyramid. At the bottom of the pyramid are data engineers and infrastructure teams that are supporting an increasing number of users of data. And that user of data and their demands are actually growing very rapidly. If anything, in the past year, with generative AI coming to the forefront, this demand has increased even further with an even greater variety of data now needing to bring in unstructured and document data into the flows. The way this inverted pyramid finally stabilizes is two factors. On the left, we look at the automation that can help these teams. And automation comes in form of many different capabilities with things such as automatically generating connectors to new systems, automatically modeling the data in many cases, and automatically figuring the scale. What also comes along that helps teams to scale is the collaboration part. And the collaboration is about people who are experts in data and understanding of data to work with people who are experts in data systems. And that comes with no code, low code, and even pro code capabilities. And all of that coming together is what brings scale and reliability into how the data function works. And now you can build your applications and scale on them. To go further and talk about how this all works, let me switch to the next slide. To talk about that, when modernizing, we need to think across various data management tasks, including data integration, data discovery, data preparation, cataloging, and governance. And it starts with capturing metadata and applying machine learning to metadata and then enabling automation with that. So that becomes a core part, and taking that metadata into our architectural approach is an essential part to becoming capable of supporting those increasing demands that come to the data teams. Now, for those who are familiar with data fabric or data mesh approaches, metadata serves as the connecting glue for both these approaches. Applying intelligence to metadata is the core enabler of data fabric, and metadata is also a key ingredient in generating data products that data consumers can trust and can use. So I'm going to go a little bit deeper into what does it mean when we talk about metadata, and to understand that metadata actually comes in many forms and shapes. So here we take a look at something very simple. You have, let's say, a spreadsheet, and in a spreadsheet, you have first name, last name, email ID, for example. What is the metadata associated here is something like what is the schema, which you can infer, for example, very easily. In this case, how many records are coming in, what is the timestamp, when is this coming in, what is the name of the file, if we process the data, how long does it take, and so on. On the right-hand side, we look at how might this metadata change over time. So let's say now we also have phone number that is coming in. So now the fact that the schema got updated, how many records are getting processed now, and what are the changes also in characteristics of data. So as we go deeper, you will see that metadata actually comes in many forms and flavors all throughout the data processing. And here's a quick example of how you might want to understand and perceive metadata. For example, a change in schema could lead to even further information like when did that happen and what is the version associated with that. So going further a little bit into the metadata aspect, it is also important to see that metadata actually can be generated in many parts of the data processing cycle. So for example, a data connector itself can capture metadata, for example, from a database as a schema. And in addition to that, metadata also gets continuously generated. We consider this as active metadata throughout the process of working with data. And this type of information can be further used to tune how we work with data. So let's take a quick sort of view of different ways in which metadata can generate capabilities that may not have been possible before. So if you think about data credentials and rate limits and API documentation, using that information, for example, allows us at Nexla to help generate connectors and connector configurations more easily. Looking at data samples, the schema, logic helps us produce data product entities. Understanding the data characteristics helps us monitor the data better and automatically. And pipeline instrumentation allows us to bring in auto scaling. And we'll look at an example for that as well. So let's look at, what are some of the practical benefits of using this metadata-driven architecture. So one of the benefits that we see is on the left-hand side, we have been used to building or using different type of data integration tools because of variations in data. Where does the data come from? Where does the data go to? What velocity is data to be processed? And for each of those, we are used to a separate tool, like an ETL tool or an ELT tool or a streaming tool or a reverse ETL tool, and so on. Now that has created a mechanism where you have a whole bunch of point tools to work with. What happens when we start to leverage metadata? For example, what we do at Nexla today is the understanding of data that we build as we learn the data and its structure, we end up creating these virtual or logical data products. And these data products become sort of an anchor entity, which give a unified representation to data. So as a data user, you don't have to worry about whether the data started as stream or an API or a file or an event. You work with the same consistent data object representation that you're used to. And now that data object can be connected to deliver data into all sorts of different places. Now, separating this design from the execution means that depending on where the data is coming from and where it's going to, our system is able to run either batch, streaming, or real time. So what we are doing here in a nutshell, and a lot of detail to get into, which I'll skip, is that by being a metadata first architecture, we're able to converge different types of data integration patterns into one tool that is simpler for people to understand and work with and collaborate around. So let's take another example, a little bit more specific to a customer case. And here I want to talk about one of our customers, which is actually a top marketing and advertising data platform. So in this case, what happens is that the company works with user lists, and those user lists, for example, are matched to different audience segments, and as process of that become targetable entities in different ad platforms. So in this case, data is being read from, let's say, some files or APIs. It goes through a certain amount of processing, for example, and then can push into different platforms. Now, different platforms will need data in different ways. For example, Facebook takes an API, and a trade desk would take a file, and so on. So the ability to now run all of this at scale across billions of devices and users is very critical to business execution, because you're taking those few billion records and pushing them across multiple platforms. So let's take a look at how metadata plays a role in making this scalable. So when users come into our product interface, for example, they're able to choose how much velocity do I want, or how much resource do I want to maximum allocate to run this particular pipeline. So you completely visually design that and give a hint to the system that my goal is to get it done, let's say, in half a day, and it would otherwise take 2 days to run that. So I'm going to give a hint that run it at 4x or 8x speed. When we do that, the underlying metadata about how much time is it taking to ingest or transform or process or write, or what is the rate limit of that API we're pushing the data into, and how to handle that rate limit, all of that information sort of comes together into the execution engine in such a way that the system can start to dynamically scale. And in a very quick visual on the bottom left side, you will see that the number of containers, for example, that are being allocated to reading data are increasing as the system figures out that the consuming system can handle a higher rate limit, and then keep pushing the boundaries until it sees that this is the maximum throughput it can do, and that's the max performance it can get. And in process, it may be generating or processing multiple streams. So when we take a look at the real outcomes that come with that, in real world, what we have seen, for example, in this particular case, is something that took 36 hours and sometimes even more than that into 2 to 3 days became a 17-hour process that is being designed in a very simple way. That metadata architecture, that abstracted data representation became easier for people to use, but then the leveraging of metadata to run and actually do the data engineering and the data processing meant that they can very easily increase the velocity of execution up to the maximum limit that the end systems can handle. So with that, I'll wrap up and just share that taking a different approach to architecture can help systems be more modern and more scalable and more flexible overall. Thank you.
Thank you very much, Saket. I have a question for you. If you're making it easier for people to work with data, what are the security and governance implications?
Yeah, those are huge. I mean, we have talked about democratization of data, but democratization had been discussed without a governance framework. And what we are talking about in collaboration, in one of the key pillars of making your data processing scalable, is one where people can work together. So when we bring governance into this play, and when we talk about these abstracted data objects that can be collaborated around, I think governance becomes extremely important. And so, yes, we do want data usage to become easier because that creates business value, but at the same time, absolutely essential to have governance.
Understood. Dhruv, I know this is a topic you're focused on at Acante. How much of a friction point are data security and governance in modern data stacks?
Yeah, thanks, Stephens. Thanks for having us. When we started Acante a few years ago, this was exactly the topic and the friction we kept hearing from some of the forward-leaning data teams, and to the point where this inspired us to start Acante. And that's really the problem and the mission that we're on, to help these data teams unlock this tremendous innovation power of their data without compromising on the security and governance requirements that they have to invariably solve for. And so, what we've built at Acante, just jumping in, is a single platform for data security observability and data access governance, focused on this modern data stack. These are the data architectures that you just heard about from my co-speakers, Saket, Jessica. And ultimately, what we are doing is helping these, empowering these data teams to deliver fast, secure, and compliant access to data. If you just look back over the last decade, and you peek over the fence to what your security counterparts have been doing, as a lot of investment into traditional cloud security, securing those web and mobile applications, running our business, and a whole host of cloud infrastructure security solutions that they've deployed, CSPMs, API security, container security, and so on. But it's pretty evident over the last several years, and probably increasing even more so now with all these new AI workloads, that engineering teams are increasingly focused on these new data-centric applications, be it traditional analytics and reporting or forward-looking model building, AI workloads, and so on. And all of these applications run on this modern data stack. Pretty much all the enterprise data that we have, including backups and replication of our operational stores, but our HR data, our product analytics, our user analytics, CRM, all of that lands up in these data stacks. And this is almost 100x growth, larger attack surface from a security standpoint. And it turns out that the security controls, the governance controls that we have out here are much weaker and much less mature. To the extent that, the intuition with which we started the company is sort of becoming almost common knowledge now, with market research showing very clearly that security has become the top barrier to the adoption of these modern data platforms, right? And the reason is that there's a lot of power that these data platforms are exposing for the business. We're able to do all sorts of analytics, run all sorts of different workloads for modeling, for analytics, for reporting, and so on. Data movement has become extremely simple, thanks to companies like Nexla and others. Transformation of this data, and there are so many new protocols for sharing this data between teams, between organizations, with your partners. But all of this, what this does is creates a whole new set of proliferation of access to this data. And that is creating all sorts of new security vulnerabilities and data leakage risks that customers are worried about. So when we talk to customers, over hundreds of customers that we've talked to, we sort of synthesized 3 or 4 very common questions that the data teams are worried about or are being asked questions from their security counterparts. The first question is, it starts with that basic concern. Are these data platforms themselves configured in a secure fashion? And as drifts occur in their configuration, are some of these drifts moving towards an insecure state? How can we monitor that and ensure that doesn't happen on a continuous basis? Then the most common question that that data teams are struggling with is, we've thrown all this petabytes of data into these systems. How do I know where my crown jewels are, where my sensitive and critical data is across these lakehouses, these cloud data platforms? Until I know that, I can't build the right kind of security program around it. I can't enable my security counterparts to do their job correctly. And then the problem that every single team is grappling with is, how do I manage the access to this data? We really need to regain the visibility and control of who can access what data for what business use case, because this is critical from a security and a compliance reporting standpoint. And lastly is the age-old problem. We need to make sure that these crown jewels are not leaked, either through accidental misuse, an honest mistake by an engineer, or through malicious bad actors, right? And these are the questions that Acante has radically simplified for data engineering teams, so they can focus on their analytical projects and almost have security become the easy button for them at scale and completely automated, right? And so just to have a quick look at the platform, that the data security platform that we have built. We heard in the previous talk about a lot of the metadata and how it is enabling all sorts of data engineering magic. It turns out a lot of that same metadata can be used for security insights and inference. Right? So we go in, build on top of the native controls on all of these variety of data platforms, and we pick up a whole host of metadata. There's a lot of data attributes, lineage of how that data is transformed, all the identity and privilege data, the sharing permissions and so on, the security configurations of the entire platforms, and lastly, all the usage, runtime access usage information about every single query. We take that and build a fairly complicated security graph, which sort of underpins the core technology and the core use cases that Acante is able to deliver. First and foremost, there are whole use cases around data privilege management. How do I make it easy to provision access to data? How do I make sure that that the privileges granted are close enough to the least privilege mindset that every organization aspires to reach? Then are these platforms securely configured, and and guardrails for, is the data being used in a way that's compliant with my organizational requirements? Thirdly, it's about we have a petabyte order, highly automated data discovery and classification engine. And lastly, a whole set of behavioral models to detect leakage and anomalous access patterns from every single identity, both human and machine and application, right? And so end of the day, what we are delivering for customers is the ability to get to fast, secure, and compliant access to data, so that they have these robust data access governance, compliance, and security models within the organization. To sort of tie this all together, this is the platform that we've built. It brings together deep security observability for these data platforms, a whole host of insights around the data access privileges and patterns, and then the ability to control the access to that data in an extremely user-friendly manner for data teams. And we've been working with a bunch of customers, and this is just an anecdote from one of our customers where we help them make their data entitlement reviews way more automated and effective, and really eliminate a lot of their over-provisioned and risky accesses. And this was core to the PHI commitments that they have as a healthcare organization, right? And so, to close it out, trying out Acante is extremely easy. If you find you're struggling with similar challenges, you're having this constant pushback from your security teams, it's a zero hassle trial. Within hours, we're going to be able to discover your sensitive data and give you a whole host of security insights that really simplify the bring up of your platform and your ultimate goal, which is democratization of data. Just 5 minutes to get going, and as I said, highly automated platform that we've put together. With that, Stephen, back to you.
Thank you very much, Dhruv. Dhruv, how is the adoption of new AI technologies impacting the requirements around data security and governance?
Yeah, that's a big topic, Stephen, and something we hear from and work with our customers all the time. There's a whole host of security concerns around AI and LLM adoption. And we've seen several enterprises block LLM access due to security concerns. But there are two common, there's many problems, but two common themes, concerns that we keep seeing. One is around how users interact with these models. One of the examples is prompt injection. Are those models being tricked to deliver by questions, to deliver answers and data that they shouldn't be giving? And on the other hand, what is the kind of data that's actually being used to train these models in the first place? And you can infer very similar data access governance concerns here as well, right? And Acante addresses several of these concerns for our customers.
Understood. Sean, there is a lot of talk in the industry about the importance of context and explainability in AI systems. How big of an issue is this?
It's good day to everybody, and thanks for having me. I'm Sean Martin. I'm the CTO at Cambridge Semantics, and short answer, Stephen, to your question, I'll probably cover a bit more about that as I go through my presentation, but it's very important. The reason being that the generative AI, which is the most popular AI at the moment and probably the most accessible, everyone's using ChatGPT, but the underlying LLMs that are used to deliver that technology, they work best with a lot of context that ground them. If you ask ChatGPT a question like who the founders of Cambridge Semantics, it'll get a couple of us right, but it'll also make up a few people, because the way it works is really a probabilistic generation of text. It's not a true store of knowledge, at least not at this time. And so what really makes those systems work very well is grounding them in actual facts and saying, within this limited amount of text, the answer is in there. I want you to generate some sensible text about that. So context is everything. And a lot of what we look at at Cambridge Semantics is how to put in that context. And we're taking a very wide view of this, because it starts with essentially a next level look at data integration. If you look at the slide I'm showing at the moment, on the left-hand side, you've got pretty much what everybody's doing at the moment, which is all these siloed systems that all are independent. And really, the answers people are going to be wanting from generative AI cut across the questions they want to ask, and the answers are going to cut across the data in many siloed systems. So what we're able to do with the ANZO platform, which is what a knowledge graph platform that Cambridge Semantics sells, is provide a way of connecting up all that data, no matter how complicated it is, and whether it comes from unstructured sources or structured sources or semi-structured sources. All of that data can be amalgamated and harmonized so that it is connected up in a way that is ideal for presenting context when you're creating a generative AI solution. Now, if for those who are not familiar with knowledge graphs, these are some of the attributes of a knowledge graph that make it very good for integrating data, but also very good for integrating data, particularly if you're targeting generative AI type problems. So one thing is the data can be very complex because you bring it in from lots of sources. It's not just a table or two. It's potentially many tables representing all the different types of things in your organization and how they connect to each other. The other thing that you can do with a true knowledge graph is you can describe all this data using what is known as a semantic layer. And we use a standard called OWL from the W3C. It's ontologies is another word, or ontology model, not to be confused with the large language model. It's more about it's kind of like a schema, except that it's data. And what that ontology does is it elevates the description of all your data to the level at which humans understand that data, which is very convenient if you've got an LLM that's been trained on a lot of text, and that text is really relationships, lots of sentences that describe things and how those things are related to one another. So the convenience of using an ontology to describe your data, as opposed to these low-level column names and random attributes and whatever the app developer thought of. Instead, you need to raise it up and make it unambiguous, because when it's going to be used as context to answer questions, you want it to be at the same level of meaning as the data on which the LLM has been trained. So knowledge graphs are particularly good for holding that complex data and also imposing that semantic layer. And if you can make it scale to a lot of data, and you can ask lots of queries of it very easily in an ad hoc manner, that's another very important attribute. You need to be able to, users are going to ask whatever they like. So unlike relational SQL databases, which you pretty much have to set up your schema around the questions you know you're going to ask, users will ask whatever they like. So you need a system that not only lets you integrate a lot of complex data, but ask ad hoc questions without having to have special indices or schema. So that's what our knowledge graphs can do. This is kind of conceptually what it looks like. Lots of different data sources of all different shapes and sizes. And we create a graph or a network view sort of representation of that data, and we give it human level meaning using ontologies, that semantic layer. And then we put it all into our system, or rather, as we bring it into our system, we automatically turn it into these graphs and provide these ontological models. And once it's in our system, we can figure out what the connections are to essentially create edges in the graph that connect the different data sets together, so that now when you ask a question, you can traverse the entire graph to get your answer. So by connecting everything up, you have a way of connecting and hopping across the graph to get the information you need. On the right-hand side, you can see the kind of consumption models, and the bottom one is actually something we call the Knowledge Guru, which is a chat interface into the knowledge graph. But we also support dashboards. We can sort of take a tabular chunk of the graph and show it up in something that's used to tables like Power BI or Tableau. We've got APIs for applications. We've got our own dashboarding tool which understands the graph and can create graph visualizations. But the most exciting thing is Knowledge Guru, which is something where end users can just start talking to their data. There's an avatar that represents the data in their graph, and they can ask whatever they like without having to make dashboards. They're just kind of making dashboards on the fly in an ad hoc manner. This is the architecture. I don't think we need to dwell on this. Anyone who's really interested, but there's a full architecture, including the most important piece, which is this ANZO graph system, which is an MPP, massively parallel data warehouse, but for graph, or specifically knowledge graph data. This is what gives us our scale and the ability to answer, form questions and form them into queries of any shape. So that's a very important key piece of technology for us. Obviously, everything runs with Kubernetes, and we can deploy it and so on. But that's pretty much table stakes these days. So how does this work? Well, the language we use for queries is a language called Sparkle, which looks like this on the right hand side. It's the sort of top right hand box. I don't know if my mouse is going to be, you can see where I'm pointing, but it's the top right hand box. So that's the query we want the LLM to generate for us. But and on the left hand side is the question the end user asks, just in natural language. So how do we make that translation? And what you can see is in the bottom two left hand boxes, essentially the ontology mapping between the low level description of the data and the human level's description of the data. And our approach at Cambridge Semantics is to allow you to essentially let a user ask a question, and then package the ontology, which essentially grounds the LLM and says you have to use this ontology describing what data you've got to formulate a query, and then you're going to pass us back the query. So it's not going to directly answer the question. Instead, it's going to formulate a query, which we then execute with the appropriate access control for the human who's sitting in front of the screen. That query executes, and the results are pushed into some kind of reasonable, either it's a textual answer or it's a chart or a table or so on. But the advantage of this approach is that it allows you to essentially have provenance and access control and so on, and get perfectly good answers, and always be able to look at a query and see what actually happened. So you're not trusting the LLM with the answer, you're trusting your database with the answer, or in our case, the knowledge graph. So context is everything. Metadata is extremely important. Ontologies are really metadata. We essentially let you produce data products. This particular application, the Knowledge Guru, is just one way of getting at your data. We also obviously support all the other ways. Our opinion, knowledge graphs are the next big thing in data integration, particularly because they're so synergistic with generative AI. With that, Stephen, back to you. Thank you very much, and thank you everybody for listening. I'm looking forward to the panel.
Absolutely. Thank you so much, Sean. We are going to dive into our panel. So I'm going to let you have at our very first question, Sean. So that question is, as the volumes of both structured and unstructured data continue to grow, what are the key approaches to address the challenges of scalability and flexibility?
So for sure, unstructured data has been unaddressed for the most part since the beginning of time. We've had search engines, whether they be internal or Google-like, but that has been about what, for most enterprises, all that's happened with them. And although we've had customers over the years who've wanted to bring unstructured data into the graph to be able to access it, they have been, unless there's been some specialized company that has developed techniques for their specific domain, their specific kind of unstructured data, it has been really very too expensive for most to deal with that. That is completely out the window now with generative AI and the ability to extract data from text using prompts. And so the ability to cheaply get unstructured data is about to go through the roof. And now, of course, we want to use it as part of our analytics, and not just to get sentiment, but to actually extract real facts. So that's going to be on the rise in an enormous way. And how to deal with it? Well, to use techniques like some of my colleagues on this call and myself are using to essentially accelerate your ability to deliver data, whether it be to tie it all together like Cambridge Semantics does, or put the appropriate speed into it with an operational database, or put the access control around it automatically. All of these things are tools that you're going to need to be able to deal with scale and still the same demands for delivery. With that inverted, I thought that inverted pyramid was exactly right. It's more and more demands on fewer and fewer people. Well, these tools that we're talking about today are the answer, and others, of course, to how to deliver in the face of more and more data and more demand.
Thanks, Sean.
Thank
Jessica, I'd love to hear your viewpoint on this question. Hey, Jessica, can you hear us? Or maybe you're on mute.
I'm so sorry. Hi. I said I couldn't agree more with Sean. It's more about choosing the right tools for your use case. As the modern data architecture is evolving, there are more and more specialized tools that allow you to uniquely address the problems that you're trying to solve. So whether you're looking to decouple your architecture or choose specific tools that scale with your needs, the most important thing is just evaluating on a per use case basis to make sure that the tool you're picking up fits your team's needs.
Understood. Saket, how about you?
Yeah, I think as Jessica said, you have to pick the right tools, and with the increasing sort of variety of data, the tools that can handle more variety do give you a lot more flexibility. And it's not just about processing and running the data in some of the use cases, it's also being able to orchestrate and manage many such complex flows and operational requirements.
Dhruv, I'd be curious your thoughts on this, particularly from a data governance and security angle.
Yeah, there's a lot of heterogeneity in the platforms, and that does create a huge part of the challenge to have a single platform that can look at the security and governance across the whole ecosystem. You may have Databricks and Snowflake and multiple clouds and so on. And that's part of the challenge that most customers are grappling with, many different languages to deal with, many different systems to learn how to secure.
Okay, let's move on to our next question. The next question is, and Saket, we're going to start with you. What kind of effort is required to move from a traditional data architecture to a modern data architecture?
Yeah, in many companies, things are already running on an architecture. What we are seeing typically is that the number of net new use cases coming are happening at a very high rate. And what is the easiest path for people to modernize is to take those new use cases and to bring them up to a more modern architecture. Because if you're solving 100 problems today, you're probably looking at solving 1,000 problems in the next 2 years. And over time, you can bring older stuff also into a more modern flow. Yeah.
Understood. Dhruv, what are you seeing when you speak with clients?
Well, the platforms have changed a lot since 5 years ago. You hardly see, things like Hadoop have been completely sunset, and almost all the new data platforms are delivered as platforms on top of public clouds, right? Which means the architecture, and from a security standpoint, the whole security architecture has changed. Just providing cloud infrastructure security is blind to the security concerns at the data layer, at the data platform layer. And so the attack vectors have changed. How you write policies, how you manage security and access policies has changed. And that just means that customers just need to look at it with a fresh lens.
Absolutely. That's a great point. Sean, would love your take on this.
Well, I'm not really qualified to talk about other people's stuff in general, but for us, we're an overlay. So we anticipate your data is going to be in very old systems and very new systems and everything in between. And we don't want a situation where there's a lot of fighting about, I've got spend an awful lot of money on this and it works. We have to throw it out. We just don't want to go that way. So we've designed our entire system as an overlay, and you build your graph as a, if you like, in-memory view of everything that you're wanting to bring in. And that makes it much easier because essentially the decision is, and more than that, with the cloud technologies and Kubernetes, that graph can be very ephemeral. It can come up when you need it. It can materialize the data that you need from the underlying systems and can go away. So we're a big believer in making it easy to adopt the technology, use modern tools like Kubernetes that sort of give you a way of creating a recipe essentially of everything from the machinery and the software that's going to run the thing through to the instructions that actually onboard the data and tie it together and create this enormous graph. All of that is a recipe that can come and go ephemerally using cloud technologies, and all of it is an overlay. So it's pretty straightforward.
Understood, Sean. Jessica, beyond the effort required, if an organization currently has a traditional data warehouse, how would they determine whether they need an operational data warehouse?
Yeah, that's a great question and one I answer a lot. At Materialize, we like to think about it this way. If you need fresh, consistent results within seconds, you need an operational data warehouse because batch-based tools just aren't going to meet your needs. But if you need results within something closer to an hour, you're probably okay putting it in a database, in a data warehouse, sticking with the tools you already have. Somewhere in the middle, it gets fuzzy. When you're at that 30-minute mark, you probably want to evaluate both types of tools and see what works out better for your use case. What goes wrong if your batches fall behind? How much can you spend rerunning things in Snowflake or BigQuery or Databricks? That's the fuzzy area, but generally, if you need results in seconds, operational data warehouse, results in hours, analytical data warehouse is how we think about it.
Got it. Thank you for clarifying that. No, that's great. So we're off to our third question. Dhruv, I'm going to let you kick this one off. Data products have become a popular topic in 2024. How do data products play a crucial role in modern data architecture? And what are some best practices you can share for succeeding in the real world?
Yeah, I'll probably take a small sliver of that answer because I think some of my panelists are closer to this. But data products essentially mean sharing of data, and that means it brings its own set of risks in terms of, have I shared the right data? Whom have I shared it with? How is it being used? Have I leaked things that I should not be leaking? Which are classic security and security governance questions. Those are some of the reasons why customers again start hitting the roadblocks. When they try and push some of these initiatives, they get pushback from the security team, which says, hey, we have no clue what's going to happen. Can you give us the visibility? Can you give us the reporting? And until then, we can't sign off. Right. And so that's where we tend to, get pulled in very often.
Understood. Saket, how about you?
Yeah, so data products are bringing a framework where we think about two entities: the one that produces the data and makes it, usable, and the other that uses it. And this sort of decoupling allows for much greater scale and collaboration across teams, because now both of these entities are not tightly connected and doing a lot of back and forth. And the approach of data products, in the way at least we approach that, is that they also give a consistent interface to data independent of the source system. And they also allow you to deliver data to different places independent of the target system. And that allows for convergence of tooling where the same sort of interface and tool can now deal with a lot more variety of data processing than could have been done before in more one-to-one or point-to-point architectures.
Understood. Jessica, would you like to comment on this one?
Yeah, I think from our perspective, we work with folks who are building warehouse native data products. So this is similar to building applications directly off your warehouse. We see people who are building them directly off Snowflake, Databricks, BigQuery. And it's useful because that's the first place where you can join across all your business's data. And here at Materialize, best practices are one, if you need the real-time data products, operational data warehouses are a good choice, but also pairing with tools like DBT for the actual management and documentation of the models to facilitate the type of collaboration that my co-panelists were speaking about.
Understood. And Sean, what are your thoughts?
Well, first of all, I love the idea. The second I heard the phrase data product, I loved it, and immediately we adopted it because it's a way for our IT partners at our customers to describe the value that they're able to bring. They call it a product; it has value, and it's really painful to get data from all these different sources and to clean it up, or it has been until you start using the tools that we're providing, and so. It allows you to provide a way of essentially giving value to agglomerations of data that can be used and provide value to some business solution or other. So I love the idea of it. From a point of view of the sort of knowledge graph, it's very useful because in the end you don't need a data product or a knowledge graph that's at any particular moment that spans every single part of the business. You really want to build a graph that addresses a particular business problem, and what we do is we have a concept we call a graph mart, which is really a metadata description, which as I mentioned, not only includes the hardware or the cloud hardware, but also how the graph will be constructed, all the instructions. So you can have many graph marts defined, each of which is essentially a data product and useful for one or more sort of solutions. And so the idea of enabling our customers to create graph marts or data products and be able to deliver them and be able to measure the value that each one provides to different parts of the business, I think is a way to help simplify thinking about the whole thing from everybody involved.
So I'm going to move on to our fourth question, and then we're going to see how much time. We'll probably go a little bit late, which we do from time to time, but that's okay. But our fourth question, and Jessica, let's start with you. How can organizations ensure their data architecture remains adaptable when it comes to supporting Gen AI applications? Hot topic, obviously.
Yeah, this is a super hot topic and actually something that I deal with less on a day-to-day basis at Materialize. So we're good for your operational data. We're used for machine learning use cases, feature store type use cases. But I think this goes back to maybe my answer to your first question, which is just choosing the right tool for the job. If you're thinking about a Gen AI application, operational data warehouse probably isn't for you in that use case, and you want to look at something more like a vector database. But I think some of my co-panelists might have more specific recommendations.
Understood. Appreciate it, Jessica. Sean, why don't we go to you on that?
Well, I would say to Jessica, we would be looking to you as an underlying store to get part of that graph be there in a fraction of a second for somebody who needs to know where is this thing in my factory or where is whatever it is at this moment. So I honestly do think the operational stores have a place to play. And from my point of view, as I argued earlier in my presentation, giving human level meaning to data and abstracting it away from all the underlying data sources and the artifacts of joins and all the things that sort of get in the way of describing how, at a human level, it all seems to make sense, right? We have we can picture all the different things in our business and how they connect. We know about that intuitively. Having your data described at that level using ontologies and losing all the artifacts of the underlying sources in terms of it makes it much easier for the generative AI to write the queries that will access that data. Writing SQL tends to be mechanical and low level, and it doesn't really get you at the semantic level or the domain level that your end user consumers are at. So for me, it's all about creating an abstraction and describing your data in the way that we think about it, and the way that generative AI appears to think about it. Not that it's actually thinking, but it seems to work very well.
Absolutely. Dhruv, how about you?
Yeah, I think this is one that my panelists are probably more qualified for. So I think they've given a lot of useful answers on that one.
Okay. Saket, I'm going to shift it over to you in case there's anything you'd like to add on this subject.
Yeah, I think the way to think about generative AI is that in the traditional data architecture, today's architecture, when we put the same query to the system, it comes back with the same answer. But in a generative AI world, you ask the same question 3 times and you get 3 different variants of the answer, all looking very right. So for the enterprise, then it becomes a very different challenge to get consistency and reliability. And how that works is you got to be able to work with embeddings and vector databases and use unstructured data. So you need that part in your data architecture. You need to still work with structured data, as Sean was saying. Bring in that real-time context. What was this person looking for to travel to? For example, if it's a travel-related question, and then also take advantage of the fact that you have to orchestrate many of these. Which model am I going to use for what kind of question, and how is all of this stitching together? So it puts a new type of requirement on, I think, the traditional data architectures that are out there, and the way organizations can remain adaptable or bring to that is, again, look at foundationally tools that are more flexible, tools that are not tied to one sort of a paradigm. And I think, and I'll go back to what I said earlier, is these are tools that are using metadata and being more adaptable rather than relying on pre-programmed sort of frameworks.
Understood. So we're past the top of the hour, but everyone has stayed with us past the bell. We appreciate that. But I think we're going to wrap this up with one more question. It's something I always like to do to offer all of our speakers a chance to kind of provide final remarks. So one last question. If there's one thing you'd really like our attendees today to walk away keeping in mind, what would that be? And Jessica, why don't we start with you?
Yeah, I think as many of the co-panelists have said, data is moving fast. There are new different products and things that are available every year. Some of them look pretty similar. Some of them look pretty different. I think evaluating these tools in terms of how flexible they are, how well they unlock new use cases, and how easily you can migrate to them is important. And just keeping in mind that there probably is a right tool for your use case coming up. There are new things and new use cases being unlocked every day with advances in the modern data stack.
Fantastic. Saket, how about you?
Yeah, I think the one takeaway I would say is that your needs are going to only grow faster than you can imagine. As Jessica said, it's very important to have that sort of framework when you're approaching these as architecturally what is designed to take me further and longer. And I would say that definitely there are many new sort of approaches that have come up and been looked at that can deliver that need for you.
Understood. Dhruv, why don't you go next?
Yeah, one of the key learnings we've had over our journey is that data teams really need to be part of the data security solution. It isn't just a CISO problem. They're responsible for their data. They're hence accountable for the security of the data. And for us, that has meant that the kind of tooling, the security and access solutions that we provide should be built specifically with the data teams in mind and should work seamlessly with their data tooling ecosystem.
Thanks, Dhruv. And Sean, last but not least.
Well, very briefly, a bumper sticker. Give your data meaning. Use a knowledge graph to give your data meaning. In 2024, that's going to just pay enormous dividends in your ability to deliver data products more quickly. And some of those products are going to be amazing, almost magical generative AI solutions on top. So give your data meaning. Human meaning.
Love it. You should patent that, on bumper stickers.
I don't know if I'll allow you patents on bumper stickers, but we could try. Maybe a trademark.
Yeah, we'll see. Well, listen, I know there were, a number of attendee questions we couldn't get to today. I feel like we could probably continue this discussion for another hour, but of course, people have places to be. But I'd like to give a huge thank you to our speakers today for doing a fantastic job with their presentations and with this discussion, providing their insights and expertise for us. So once again, Jessica Laughlin, Head of Product at Materialize, Saket, Co-founder and CEO of Nexla, Dhruv Jain, Chief Product Officer at Acante, and Sean Martin, CTO and co-founder of Cambridge Semantics. So if you in attendance would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. It will be archived, and you will receive an email from us once that archive is posted. And if you would like a PDF of the deck, you can go to the handout section on the console once the recording is live. Also, as I mentioned earlier, you could win this $100 Amazon gift card for participating in today's event. The winner will be announced on February 29th. We'll let you know if you're the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.